Hello guys, you're welcome to the 13th video in this series. In this video, we are going to be talking about literals. Literals, spelled literals, just like that. Now, what are literals? Well, I'm going to just show you because I don't really think I can explain it. So say for example you wanted to, and by the way, if you're wondering why I cannot explain it, I actually found that from here, where I was reading the Rust by Example book. So you can find that on the website rustlang.org. I think that's what it's called. So if you go to the Rust website, you can find the Rust by Example book. So if you want to follow along, so this is what I'm using as guidelines for the tutorials, in case you're wondering. So these are the literals that they actually explain here. So we have the numeric literals. Okay, so they're basically talking about how to specify the types for literals. So literals are just values like 2, 10, 10.4, 253, and things like that. So those are literals, and that's what we're going to be talking about in this video. So basically, what I wanted to explain about literals is, say for example we have a variable called a, and I say it's 23. So what type is this variable exactly? Now normally this type is going to be an I32 as far as I know. So let's check that just to make sure. You can see that a is actually what, an I32, as we expect. Now this is all cool, this is fine, but what I want is actually an I64. So I could do that here by doing I64, but there is another way to actually do that using literal suffixing. So you could put the type here, and I actually kind of like this. I like using this sometimes, but this is kind of less readable if you think about it, but I still like to use it anyway. But Rust also allows us to do crazy things like this, put an underscore after it, and then you can put the type. So this is actually cool. And just to show you that this is still going to work as you might expect, I'm just going to print it out because some of you like for me to just show you and don't think I'm lying. As you can see, a is still 23. So if you wanted to write a much more readable literal like this, then you could have 23 with an underscore, then your I64 should come at the end. Alright, and you can do that with most of the literals that are actually in Rust. So you could do 23 I32, let a equals to 2.1 F32 if I can type that, then equals to 1 point whatever F64. So you just have to suffix it with the actual type, and that's gonna work. And as you can see, you can also put the underscore at the end just to make sure that the literal works as you might expect. All right. So for example, 1U size. So basically, all of this is how you suffix stuff for literals. And I believe that is all there is for literals in Rust, right? So they also explain the size of a variable. So and that's what I'm gonna be showing you guys in a minute. So in order to do that, let's just say we wanted to get the size of, U size, I believe. So there are different ways to do that. So I want to get the size of an I64. An I64 is actually 4 bytes, but let me show you how to do that in code. So I'm gonna print size of I64, and I'm going to do std and size of. Okay. So we're gonna pass in I64 here, and now yeah, I believe that's it. Nope, I actually need to move this here, I think. Yeah, so now if we're on the program, we should see size of I64 to be 8. Alright, I said 4, that's actually 8. 4 bytes is I32. So if I actually if I want to do for I32, then you can see that if I come here to change this just to make sure that everything matches. Cargo run, just like that. You can see that the size of I32 is actually 4 bytes. So that's basically it. That's how you do it. If you want to get the size of a particular variable, that's actually simple enough. You just gotta use size of value. Alright, and the size of value is just going to be, for example, a, and if you run the program, you should see that I64 is actually 8 because the A is actually U size, and the size of a user is actually 64 bits because my machine is a 64-bit computer, and that's why you get it. So if you're running a 32-bit computer, it's probably gonna be 4 bytes, which means your computer is 32 bits. And if you, just to show you what I'm trying to say here, if A is declared last here, this is 32 bits, so this will actually give us 4 bytes because I moved this variable to the end here, and as you can see we got 4 bytes as you might expect. And that'll be all for this video. I will see you guys in the next one. Have fun. Bye bye.